Yeah, we continue from the example 7 just now. So you draw the free body diagram for the crane, for the box, or for the object. W point down, 2T up because you got two cable here. And the datum is given SC go down positive. So just for insurance, you just label, just let you know why positive go down for this object. Then you do F equal to MA. So W minus 2T, because positive go down positive. You are following the datum given. Then MAC, you modify accordingly. You substitute the value, you get first equation. Here you got T, you got AY, two unknown, only one equation you cannot solve. So you need help from the pulley equation. L equal to 2SC plus SP. Time differentiate, you get velocity and also acceleration. So here, you know that the P and AC, AC moves slower than AP. So AC equal to half minus half AP. Minus means opposite direction. Can also mean the acceleration. Okay, once you get that, you substitute the acceleration. Again, there's typo error in this question. This 1.2 meter per second should be 1.2 meter over second square. It is acceleration. So the unit is wrong. You substitute that, you get your AC. You substitute back into 1 here. Your AY is your AC. So you substitute back here. You'll get P equal to 182.2 Newton. AC here, negative, is also because it tells you that the object actually move up. Okay. So once you do that, you have a cable move in typo error here again. It should be m stroke s square. So you have force multiplied by velocity. In this case, is the tension cable. Tension in the cable multiplied by velocity of P. You put in the tension cable, the tension in the cable, 182.2. Because the cable here is the same. The tension in the same cable. Multiplied by velocity 0.6. Okay, yeah. Velocity is given here. Velocity 0.6. You get power. So this is the power you need to lift the crane. The question asks you what is the power need to supply to the motor, because motor efficiency 85% only. You need to tell the supplier what kind of motor you need. Okay, so this in the system, in your factory or in your operation, you need 110 Newton meter or joule over second power or watt. You need 110 watt kind of work. Then you tell the supplier will tell you the efficiency at 85.85. So you pull out the equation, efficiency equal to power out divided by power in. Okay, you substitute the value. You want to know what is your input. Okay, this is your output. This is what you see or supplied by the motor. So you inverse the equation. You get 129 watt. You need to tell the supplier, you need to give me 129 watt motor based on the efficiency 85%. Okay, anything less than here, less than this, the motto less than this one, you won't achieve the acceleration of 1.2, and you won't get 0.6 at the instant velocity at p. Okay, so this is important when you go to work later. All the machine will have efficiency. Okay, we go a little bit more. 3.5 is conservation of force and potential energy. This one is conservation of energy, conservation of force and energy. So means that conservative means there's no loss of forces, there are no loss of energy. So equal 0, everything equals 0, or before must equal to after. Anything that you did before must equal to after. Okay. Now, for example, what are the conservation force? The work of the force is independent of the path. The path, the keyword here is the force. If you use the conservative force principle, the force, the force must be independent of the path. If you want to calculate the work of the force is independent of the path, depend only on the initial position. And we can classify this one as conservative forces, like just now the W in the sliding, the boy sliding down, the W. So it doesn't care what is the shape of the slide, but it only care what is the initial and after. This is W. For example, weight, it only you only look at the final and initial position. Okay. Second one is the spring also. Okay. For example, spring. Spring also, when you calculate work done by the spring, also you only look at what is the early position, what is the end position. Okay. However, if you look at this diagram, when you slide object at a certain angle, there's a friction there. So when there's a friction there, friction is depending on the path. Friction is depending on the path, the surface that it go across. So friction is non-conservative. Friction is non-conservative. So it meaning that if the question asks you to apply conservative principle, friction you have to take out in your calculation. Okay. So next we introduce you potential energy, whether you're very familiar. Potential energy equal to mgh is what you learn in the secondary school and also your foundation. In this module, to highlight your date, there's an axis of datum. In your SPM, STPM, or in your static, your datum always start from below, meaning your object will always above datum in your secondary school exam. Your datum always above. So here, by paying attention to the datum, if the object is above the datum, you will get positive potential energy charge to the object, where mgh you get positive. If the object start from below the datum, you will get negative potential energy because the h is negative from the datum. And if the object is on the datum, there's no potential energy. Okay, so it depends on where you refer to in this case. In the engineering dynamics, you're looking for datum. You're not looking for the height. You're not looking for the from the sea level or what. So your STPM, your SPM, all from the sea level and all this. But for this module, you are looking for datum. Okay. So this one. And elastic potential energy, this one, as you can see, spring potential energy give you by positive kx square. Okay, positive kx square, and it always stay positive for spring. Spring always positive. No matter you scratch it or you compress it, both give you positive energy. Okay. So these are the two forces that you will consider when the question asks you to apply conservative of force and potential energy in your solution. So if you see spring and gravity sure have one. Only when you see spring, the total potential energy, you need to add two component. One is gravity component, one is the elastic component or spring component. Okay, so this is you need to watch out lah for this one. Okay. Then work done by a conservative force equal potential energy number 1 plus potential energy number 2. So you can pull potential energy before over here plus work done by the conservative force equal to the potential energy after. Don't mix this one with the earlier kinetic energy. This formula is for conservative force only. What are the conservative force? That only depending on the path, not path, depending on the position, then it create work. For example, weight. For example, what else? Spring. What else? These two. Okay. So, for example, if you have a datum over here, and there's a sphere over here. So when you use potential energy, your equation should be Vg means gravitational force plus Ve elastic component. So you will see the mgh for the sphere that below the datum will give you negative value because it's below datum. So negative mgh or ws, the distance from the datum. If you put h also can, but make sure in your diagram, in your answer diagram, put h there so I know what you mean. And elastic or spring always positive energy, half kx squared. Okay, half kx squared. So if the particle move from S1 to a lower position, work done by the force will be V equal to V1 minus V2. V1 means position 1 minus position 2. So you'll get this equation. So total work done by the conservative force equal to V1 minus V2 means potential energy at position 1 or starting position minus the end position. Here, do not link with the pathway. Take note, this equation do not consider the distance traveled. It only look at position. So you have two set lah. Okay, this equation is just elaborate if the object is below datum. If the object on the datum, then something need to change in the equation already. It's on the datum, then W0, Kx also 0 if it's on the datum. Okay, this one is more on elaboration, or this one. So if it's 3D, then work done by the conservative forces will be V1 plus V2. So V1 from this position minus the second position, what is this position? So it's still 1 minus 2, it's just in the mathematic form. If you can't remember, it doesn't matter, not very important. It's just need to recall the Cartesian analysis. Cartesian vector analysis. If you're seeing three-dimensional, you just write du equal to, or delta u equal to 1 to 2, equal to force multiplied by the distance traveled, f dr. Change your f into ijk. Dr change to ijk also. Okay. So this one just for your info. Just for info. So just for info, for elaboration, for derivation of equation. This one is just to introduce you. You'll see this one is in the Bernoulli equation in the if you study hydraulics later, you will see this symbol. So this one also, this partial differential in ijk, you use an inverted triangular. You see this one in hydraulic or anything linked with the flow, you will see this one. Partial differential, this one is another chapter. For this module, I won't ask you partial differential equation. It's also called vector operator. Vector operator. This one for your info. Important is this one. Important is this one. So if the question asks you conservation of energy, so it consists of kinetic energy plus potential energy plus work done equal to kinetic energy after potential energy after. This is called principle of work and energy. And you write the full including the potential energy. When you need to use this energy, when you see in the photo, in the question, you see datum. When the question gives you datum, very high chances you need to use this one. This one, the earlier one, delta U equal to T2 minus T1. This one, in this kind of question, you don't see datum. You don't see datum in this kind of question. If you see kinetic, there's no datum. And usually this one you happen in a straight line. Okay. So if the question extends, it will ask you consider only conservative force, then you cancel the work done by the non-conservative, because here you also consider friction. So you take out the component, energy before equal to energy after. So if the question asks you to use conservation of mechanical energy or conservation of energy in your solution, you write energy before equal to energy after, then you consider kinetic energy and potential energy for both sides, left-hand side and right-hand side. Yeah, so the equation for the first one here, principle work of energy, is a full equation for chapters 3. It depends on the question. If you see datum, most of the time you need to write V1 and V2 in your equation. If you don't see datum, most of the time is only consider kinetic energy. Then the question, it will extend or ask you consider conservation of energy. You write this equation, T1 plus V1 equal to T2 V2. Substitute half mv squared equal to mgh equal to half mv squared per mvh. Again, V1 here got two components, gravity component and spring component. Got two. V1 here. It depends on question. If question didn't give you spring, then you only consider gravity effect. If you see spring, then you need to include spring over here, half kx squared in here, mgh plus half kx squared. Okay, this is just proving the conservation of energy by using the ball location. So if the ball start from a h, drop from a h here, for ground is your datum, let's say. So to prove this one valid, you start from this one. Energy equal to T1 plus V1 So energy at this here, you don't have velocity. So velocity 0, half mv squared, v0 here. But potential energy maximum, because mgh datum is here. So it's above the datum. So you are charged up the potential energy. So you have positive mh or mgh. If you do second one, half mv squared plus half mgh, because h is half. Combine, you get mgh. Here, velocity maximum. So you get half half mv squared. Here. This is just to prove the equation. I won't ask you to prove. Okay, this one you read for your info. Important is this equation. Okay. So this one is your homework. Go and read. Okay, so this one is, we'll revisit this one when they go into composite body or rigid body. You will see this and this equation again by sum up all the body together. Okay, example 8. There is a experiment test setup where you want to test the plane, crash plane, how to crash a plane. So you tie a model to a rope with 20 meter over here at point A. Then you cut the rope, so this one will swing and hit B. So before you solve, you look at the motion. What kind of motion? Is it linear or curvilinear? It's a linear motion or curvilinear motion? Curvilinear motion, because it's tied to a rope, it will move in a circular motion. So when you have circular motion, remember when you draw free body diagram, there's a normal and tangent direction, normal tangent direction. So, and the normal tangent direction will give you acceleration equation, A equal to an plus at, an equal to v squared over rho. You have your rho already. Okay, so you can find your A or V. Okay, you have plane given mass, hoist until theta equal to 60 degree. So you hoist up to 60 degree. Then the pullback AC release when the plane is at rest. So V equals 0, V1 0. Determine the speed of the plane just before it touches the ground when the theta is 15 degree. So from 60 degree, maximum it reach is 15 degree. Also, what is the maximum tension developed at the supporting cable during the motion? It asks you what is the maximum tension cable here. Here or here. You have only two positions. Here, either here maximum or here maximum. Ignore the size, means the shape of the airplane, and effect of lift caused by the wing. So how do you solve this kind of question? Of course, when it comes to question, we will give you more information, like guide you what principle to use. Okay. This one you read. So you draw the plane from A position. It's a circular motion, so there's a normal and tangent direction. Weight always point down. Okay, weight always point down, and there's no engine turned on, so there's no forward force, and only work gravitational only work that way. So there's a tension cable in the normal direction. That is the normal direction T with 15 degree during the crash. During the crash. At position A, the theta will be 60. When it crash, the theta here become 15. Okay? Because the question already hints you you need to focus just before it crash. So you focus just before it crash. Just like the question just now, the boy sliding down, it tell you that position B is your focus. So potential energy, mgh. So datum is given on the top. So datum go down. So you use conservation of energy over here. Kinetic plus potential before equal to potential kinetic after. You put in the equation. Half mv square equal minus mgh. Why minus? Because the plane is below datum. Okay. Because the datum is on the top, the object is below. If the question flip, we pull the datum on the ground, this one become positive. Just be careful on the datum. If we give you a same question, we just change the datum over here, your equation negative here become positive. Because your object, if the datum is below, your object is above the datum, then you become positive. So back to this solution, minus, okay, you substitute all the value. Before start, no acceleration, no velocity, 0. The mgh, you substitute mg, h is over here. This is your h. Okay. 20 cos 60 over here. So this is triangular. This is a theta. Cos is the side and hypotenuse. So this is the h. Below datum, negative. Equal to after. So after you have a velocity, you don't know. So you remain v at second location. But you know the h. The h is over here at 16. Over here. 16 also cos 15. The length is 20. So here you only left out one unknown, which is your VB. So your VB is 13.35. Again, your VB is tangent to the curve. This is your VB in tangent direction. You use equation of motion again. F equal to ma. If you cannot find anything that link to the normal force or tangent, use F equal to ma. Because in the free body diagram here, you have tension cable, you have W you can find, but tension cable or this one touch down got normal force one, then F equal to ma will help you. So F equal to ma, find all the normal direction. You need to split the W in normal direction. Okay, so positive go up because normal pointing into the curve. Minus mg cos theta equal to m acceleration in normal direction. So v squared over rho. Rho you know is 20. Substitute the value in, you can find your tension. Okay. And again, you can find your acceleration in tangent direction. Then find the resultant, find the angle of the acceleration. Okay, because this is a tutorial question for conservative of energy, so we don't go deep into the acceleration. Okay, so you get tension equal to 14900 Newton. You can simplify into kilonewton, 3 decimal place or 3 significant figure. Here you find tension already. Do you find the velocity? You find already. So maximum tension is found. Okay, this is the last example for this chapter. So this system, you look at it, is a double spring, double coil spring. you have if you look carefully, you have spring A, spring B. You are given spring coefficient for A, spring coefficient for B, the initial length of B, the initial length of A. And the RAM R is on the top, 0.75 is from the top. Even though this one do not give you datum, you should be clever enough to put your datum on the floor, from the floor, so all your value is positive. Okay, the question asks you, we given the mass of the RAM, it gives you, you need to know, determine the maximum displacement of A needed to stop the downward motion of the RAM. The unstressed length of each spring is indicated, ignore the mass of the spring. Okay, so you need to find the maximum of A, although here got double coil, means you need to calculate the spring coil and the spring A. There are two calculations here. The focus is tell you to ask you to find the displacement of A after you find displacements of B, when the whole thing stop. It look complex, but actually quite easy. You find potential energy first. Okay, so these are the diagram that you should able to see. You draw before and after. For the energy, conservative of energy or principle of work and energy is always very helpful. You draw diagram before and after so that you see the position before and after. So here, this solution give you datum from the initial, means is from here to here, means before and after, before rest and after rest. So you will have accelerate, then it stop, or move very fast, then stop. Okay, so you compare datum to datum. So when it stop, when it move 7.5, this is before, but before, then you need to squeeze down. You need to squeeze down the displacement of A. So this SA, you need to squeeze down the SA. So SA is put here. So it moves 7.5, this initial length from the center of this one. Then it press down. You need to find the SA. So when you press down SA, you also press down SB. Okay. Okay. Why SA minus 0.1? Because the differences here is 0.1. Okay. So there is a newly developed equation from the diagram, and this one is logic thinking, more on the logic thinking. So it will, you need to see before and after what actually happened after. The focus is on SA, and you want to link the displacements of B in the term of SA. You put SB in term of SA, where you take SA minus 0.1 right here. Okay. Once you have the free body diagram, after you go for conservative of energy, means you only look at energy dimension before equal to after. There's no loss of energy. So here, T plus V1, kinetic plus potential energy. Here, remember you have gravity and spring. Here you see spring, so remember to consider mgh plus spring. Spring is kx squared. So you put in the equation. Before, nothing happened, 0, 0. Before, kinetic, no velocity. From datum here, from datum at the top, so mgh, h0. Spring unstretched, there's no spring unstretched. So 0. Equal, after, y t2 0, because it come to the stop. Need to stop the thing. So velocity 0 after half mv squared number 2 0. but your kinetic done some work there. Kinetic consists of two parts, spring A, spring B, both positive, but there's a changes of position for your data for your gravity point, which is negative because it's fall below the datum, negative mgh. The rest is a substitution. You will find SA. Challenging part is you should able to see what happened after and link SB to SA put in one term here. So you're only solving for one unknown. If you put SB, then you won't solve. There are two unknown with one equation you cannot solve. Okay, the rest is a substitution. You will find the value. You need to solve for quadratic equation because S squared there. S squared, you have positive, negative. So pick the positive value, 0.331. Okay, pick the positive because your direction go down positive. Your spring press down, positive go down. Okay, so this is how you solve. With this, you can find your SB lah if you want. Okay, so just a note there. The second root, which is because you have a square quadratic equation, second root negative does not represent the physical situation. And so on. The rest you read. Okay, with this, we conclude chapter 3. I think we stop here and see you after Chinese New Year break. Okay, have a safe and good Chinese New Year break.